Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, in the past few lessons we learned and defined many things about mixtures like types of mixture, kinds of mixture. We learned about the formation of mixtures. So I'm going to start with the very later topic today is the introduction to mixtures and their separations. So we'll be discussing with the types of mixture with the respect to the physical states. We'll be discussing the properties which exploited for the separation of mixtures and also briefing out all the methods which are used to separate the mixtures. So friends, what are the mixtures? Mixtures is nothing but a substance which consists of two or more elements or compound which are not chemically combined together. For example, air is a mixture of gases like oxygen, nitrogen, argon, carbon dioxide, water vapor, etc. So mixture may exist in any state of matter like solid, liquid or gas depending on the physical state of the components. They may be heterogeneous or they may be homogeneous. Like you can get these examples: soil, salted water, tea, petrol, water vapor, carbon dioxide, lime water, paint. What are these? They all are the mixtures, but in very different physical states. Like solid is in the solid states, salted water is in the solid dissolved in a liquid, tea is solid dissolved in a liquid, again a liquid mixture, petrol is the mixture of two liquids, carbon dioxide is mixture of gases, paint is a mixture of solid and liquid. So now we can simplify the mixture with respect to the physical state as solid in solid, solid in liquid, liquid in solid, liquid again in liquid, gas in a liquid, liquid in a gas, gas in a gas. So friends, here you have to note down that these are the two states. I'm taking the first one as a solute and this is as a solvent. I hope you have now the understanding of solute, which is the minimum quantity used to form the mixture, and this is in the maximum quantity like in the large quantity. So if you remind or just think around what are the mixtures around you. For example, if you take the solid in solid, you can see the gunpowder will be the example of mixture. You can take the solid and liquid mixture as sugar in water. Liquid in solid, you can take the example of water in a sponge. Liquid in a liquid is, you can take petrol. Gas in a liquid, you can take the example of helium gas present in water. Gas in a liquid, that is moisture in air. You can also take the example of water vapor. And gas and gas, you can take example of air, right? So let's understand what are the properties if you want to separate these kinds of mixture, which depends upon their state, that is their physical state. So here now we'll understand the properties which depends on the physical state of the constituent of the mixture and also the type of mixture. Let's understand. Let me first give you a brief of the topic, like properties depend for the separation of mixture, right? So what is the first point? First point is the mixture. Is a mixture heterogeneous or homogeneous, right? Second, the physical state of the constituent of mixture. What do you understand by the physical state or the physical properties, you can say? That is the physical properties. These are those properties that can be either felt by the sense or measured with the help of a suitable equipment like color, odor, taste, rigidity, conductivity, melting point, boiling point, also the magnetic property, so these are the physical properties of the constituents of the mixture which has to take it in the account when we want to separate the mixture, that is we want to separate the constituent particles of a mixture. So what is the third point? Third point is nothing but the different physical properties. Let's take the boiling point, the very important physical property. What do you understand by boiling point, friends? Write down. What is boiling point? It is the constant temperature at which a liquid changes to vapor state under a normal atmospheric pressure. As each liquid has a characteristic boiling point of its own. So boiling point depends significantly on pressure. It increases when the pressure is increased. Generally, boiling point is measured or reported under 1 atmospheric pressure, as a boiling point of a liquid at 1 atmospheric pressure is called its normal boiling point. For example, if you can take the boiling point of water, which is 100 degrees centigrade. What is this fourth point? It is the melting point. What is melting point? It is the constant temperature at which a solid converts into the liquid state. That is, a melting point is a characteristic property of solid. Generally, the melting point increases when the pressure is increased. So when the vibrations become rather stronger, the molecules from the surface of the solid becomes free and the solid thus starts to change into the liquid. And the process is called melting or fusion. So what is the fifth point? Fifth property? It is the sublimation. That is, ability to sublimate. It is nothing but a solid on heating or cooling changes directly into vapor states, that is, directly changes into gas. A solid formed by the vapors of the substance that sublimes is called the sublimate of that substance. Thus, the solid formed by the vapor of, for example, ammonium chloride, iodine camphor, or naphthalene balls you can see in your household products. They are the naphthalene balls we use to put into the woolen clothes. They are actually the sublimate substances which directly changes it into the vapor states. What are the other properties which depends for the separation of mixture is also one of the evaporation. We also call this the ability of volatile that is the process of conversion of a substance from liquid to gaseous state, right? As the molecule which negligibly intermolecular forces between them becomes completely free and escape as a gas from the surface for the liquid. As it is a very slow process and it occurs at all temperature, like wet clothes dry up due to slow evaporation of water from its surface. You can also see the volatile substances like petrol, kerosene oil. They all are very volatile. They react with the air very immediately. Like they react very fast with the air and convert themselves into the gaseous form. So what are the other forms? We also have one of the like magnetic property. We also have freezing points, which are actually used to depend for the separation of mixtures. So friends, now you have understood the properties which actually depend, we actually see these property when we want to separate the mixture to its constituent particles. So let's brief out now. That is the physical state of the constituent, the difference in the physical properties like boiling point, melting point, also the density, how dense the constituent particles are, the magnetic properties, ability to sublimize, volatility, solubility in various solvents also. After seeing all the properties, can I separate seawater, chalk water, rocket diamond, iron and sulfur? Can I do this? Is there any method which help me out to separate all these fours? Now let's see the methods. I'll be briefing out all the methods and we'll be discussing one by one in the future slides. Like I have divided these separations, all the methods depending on the physical states of the constituent of the mixtures, like solid-solid separation. When there are two solids, solute and solvent, both are in the solid form. Second, solid liquid. Two constituent of the mixtures are in, one is in solid and one is in solid liquid form. Liquid-liquid separation respectively, gas-gas separation, liquid-gas separation, and the complex mixtures. What are the complex mixtures? These mixtures are basically those mixtures which the constituent substance having a similar physical and chemical properties, and actually they are the homogeneous mixtures. You can have an example like sugar, hydrocarbons, or the coloring matter in ink. They all are the complex mixture which actually very difficult to separate. So let's see one by one what are the methods accordingly. In the solid-solid separation, we have mechanical picking, magnetic separation, gravity separation, solvent extraction, fractional crystallization, sublimation. Next is a solid-liquid separation. We have the methods like evaporation, distillation, filtration, sedimentation and decantation. In the next liquid-liquid separation, we have separating funnel, distillation and fractional distillation. In gas-gas separation, we have three methods: diffusion, solvent extraction, preferential liquefaction. In liquid gas separation, we have only one separating method, which is boiling. And next is the complex mixtures. These are those mixtures which have the physical and the chemical properties same, that is very similar. We have one and very important method, which is chromatography. So friends, we have methods of solid-solid separation, solid-liquid separation, liquid-liquid separation, gas-gas separation, liquid-gas separation, and complex mixtures methods. So here I end up with the briefing out all the methods. In the future slides, we'll be taking one by one all the separating methods and we'll be discussing into the details. For now, I'll be ending up this session, and here is a very simple activity for you. You just have to view this video at least 2 times. And next, we'll be discussing methods, that is the separation of solid-solid mixture. Thank you, friends.